Okay, so now let's see how can we use the heap in the priority queue. So you all have studied the priority queue in the data structure. It is a type of queue only, but with having some more properties as compared to queue. So in this priority queue, every element has a key associated to it, and the queue returns the element according to these keys. Means suppose we have like we can think about the priority scheduling, where the tasks are scheduled based on the priority of each task. So all those things are stored in the priority queue. So according to the priority of a particular task, that task is scheduled accordingly. Okay, so in this priority queue, every element has a key associated with it, and the queue returns the element according to these keys. Unlike the traditional queue, which works on first come first serve basis. So a max priority queue returns the element with maximum key first, whereas a min priority queue returns the element with the smallest element. Okay, so this is the max priority queue, this is the minimum priority queue. So this max priority queue, you can see here, this is the maximum priority of a particular task. So this can return, sorry, this will return the value 20, and this one is the min priority queue, it will return the value min. Okay, so we are having two types of heap, that is max heap and min heap. Okay, and we can simply utilize the max heap in the max priority queue or the min heap in the min priority queue. So priority queues are used in many algorithms like Huffman codes, Prim's algorithm, and priority scheduling, etc. So it is also used in scheduling processes for a computer. Heaps are great for implementing a priority queue because of their properties. Because of the largest and the smallest elements at the root of the tree for a max heap and a min heap respectively. Okay, so in the case of max heap, this will be the root, and in case of a min heap, it will be the root. Okay, so we can use a max heap for max priority queue, and we can use a min heap for min priority queue. So these are some of the operations which can be implemented on the priority queue by using the heap. So max priority queue support the following operation: insert operation. Basically, so we are just inserting an element X into a particular set or the heap, like extract max. So the extract max. So we are having basically two methods which are almost similar, but with the one difference, like extract max and maximum. Both will return the maximum element or the largest key from a particular set, but the extract max also remove that from there. But the maximum, this as will only return the largest key. Okay, so this is the basic difference in between these two, and the last one is the increase key. So basically, if we want to increase the priority key value of a particular element, then we can just increase by using this operation. So increase value of element x key to k. Okay, like assume k is greater than equal x current key value, then only the key will be increased. So these are some of the operations which can be utilized or implemented on the priority queues when we are implementing the priority queue using a heap. So let's start with the first heap maximum. This one maximum. So this operation heap maximum, it will return the maximum element. So it is not a very tedious task, as if we are having a max heap, then the topmost element will be the maximum element in the particular heap. Okay, and that will return by that can be returned by simply return a1. Okay, so this is the maximum, this is the heap maximum procedure. So the running time of this, as it is containing only one instruction or operation, so the cost for that particular operation will be O of 1. Okay, the next one is the heap extract max. तो अब दोनों में डिफरेंस है, ये तो हो गया मैक्सिमम जैसे मैंने बताया था अभी, ये इसमें तो केवल रिटर्न करेगा, और हीप एक्सट्रैक्ट मैक्स में क्या होगा, वो वहां से उसको रिमूव भी कर देगा. तो ये रिटर्न भी करेगा, रिमूव भी करेगा. जैसे सपोज वी आर अप्लाइंग द हीप सॉर्ट, तो उसमें क्या होता है, टॉप मोस्ट एलिमेंट को वहां से हम रिमूव कर देते हैं. ठीक है, इन द सेम वे. तो in the heap extract max, extract the largest element of the heap, that is return the max value and remove that element from the heap. Okay, so the idea for this particular process is exchange the root element with the last, as we have already implemented in the case of the heap sort. Exchange the root element with the last, decrease the size of the heap by 1, and then call max heapify on the new root on a heap of the size n minus 1. तो जब हम इसमें चेंज कर देंगे, लाइक दिस इज द लार्जेस्ट रूट, तो ये यहाँ से रिमूव हो जाएगा. रिमूव कैसे करेंगे? वी सिंपली रिप्लेस इट विद दिस, or simply some delete it from here, then replace this value by this. So 2 will come here. Now as it is violating the max heap property, so in this case we need to apply the max heapify procedure here. So 2 will be replaced with 4, 2 will come here, 4 will come here, like this. So 4 2 1 or 4 3, this will be the scenario here. So this is the heap extract max, and this one is the heap maximum. Okay. Acha, now this is the example like how we are extracting the we are just implementing this one. So max is 16, it will be exchanged with the value 1. 1 will come here. When 1 will come here, the heap size will be decreased by 1 as this element is deleted from here. Now this 1 is here and it is violating the max heap property. So we need to use the max heapify procedure. So 1 will be replaced with 14, then 1 will be replaced with the 7. Like, sorry, not 7, 8. Means we simply in the max heapify procedure we swap the values, or swap the value of the parent node with the largest child node. 1 will be replaced by 14, and 1 will come here, then 1 will be replaced by 8, then 1 will be replaced by 4, like this. So we can call maxify for a of 1 n minus 1. Why n minus 1? Because initially there was n elements, and after the removal of the 16 there will be n minus 1 element remain. So we have just applied this maxify procedure in this operation. So now let's talk about the complexity analysis. So here the whole process will gets executed till there is a element left there. So if n is less than 1, then we cannot extract any element from there, or we cannot delete any element. So this kind of situation is basically underflow. So you people know about it, like when the data structure is full and we are just inserting an element, then that situation is basically overflow. And when there is no element in the data structure and we are just deleting an element from there, then this situation is known as the underflow. Okay. So this condition will be checked here as simply we are deleting an element or the root element. Now max equal a1, we are just taking this one and replacing the a1 with the an. Okay, and now when a1 will be replaced by an, so when 2 will come here, then we need to call the max heapify procedure on the remaining element, or max heapify procedure on the remaining element of the graph. So this is the heap extract max approach. Now we are talking about the algorithm here, that O of 1 contribution, O of 1 contribution, and this one O of 1 contribution. So max heapify procedure will be executed here for n minus 1 time. So we can say like sorry, not n minus 1 time. So it will be executed here when single time only, because we are just deleting a single element. So the cost of max heapify is basically O of log n. So the cost of this heap extract max will be O of log n. तो देखो दोनों में डिफरेंस क्या है, इसकी कॉस्ट होगी O of 1. तो यहाँ पे हम केवल एक्सट्रैक्ट कर रहे हैं, नॉट एक्सट्रैक्ट नहीं कर रहे हैं, मैक्सिमम रिटर्न हो रहा है. और जो हीप एक्सट्रैक्ट मैक्स है उसके अंदर हम क्या कर रहे हैं, यहाँ पे उसको वी आर जस्ट एक्सट्रैक्टिंग द एलिमेंट बाय रिमूविंग द एलिमेंट फ्रॉम द रूट ऑफ द नोड. Now heap increase key. So in this operation we can just increase the key value of a particular element. So the goal is here increase the key of an element I in the heap. And how we can simply perform it, increment the key of AI to its new value. If the max heap property does not hold anymore, traverse the path toward the root to find the proper place for the newly increased key. तो जब हम क्या करेंगे, इसको इससे रिप्लेस कर देंगे, like we are just replacing this for 4 with 15. Then what we will do, we will just check or compare the value of this new key value with the parent key value. We can see here the value of parent is less than as compared to 15. As 8 is less than 15, then we will perform a swapping here. So this operation will be performed up to the root node till the all the properties of the this max-heap will be restored. So 15 will be replaced with 8, then 15 will be replaced with 14, and here no property will be violated. So the final position of 15 will be here. Okay, so this is the heap increase key operation. Like this is the example. So what we will do, initially it is 4, so now we have just replaced it with 15. So here is the property violation of the max heap. So what we will do, we will exchange all till the root, जहाँ तक जरूरत है वहाँ तक इसको replace करते जाएंगे. So initially it will be replaced by 8, then it will be replaced by 14. Now it is on its proper position. So now you can see every node value is greater than or equal or to, sorry, greater than to its child node. So this is the way the properties are maintained. So this is one animation type GIF where we have replaced the value of this. Initially it was value 2 and it was replaced by 22. And this is the whole procedure. It's 22 replaced by 10, 10 okay, 22 replaced 15, then 22 replaced by 20. So in this way, if you want to increase the key value of any node, then we can simply increase that in this way. Okay. Now, this is the algorithm for heap increase key. We are just passing here array the I जिसकी हमको लोकेशन जहाँ पे की इंक्रीज करनी है और नई की क्या है जो आपको वहाँ पर रिप्लेस करनी है. ठीक है, तो सबसे पहले तो ये चेक करेंगे कि जो की हम रिप्लेस कर रहे हैं क्या वो पुरानी वाली की के इक्वल है क्या. अगर वो पुरानी वाली की के इक्वल है तो फिर तो मतलब ही नहीं है इस चीज़ का. Then we will check here a condition. If key less than a of I, then error, new key is smaller than the current key, because this operation is basically increasing for increasing the key value, not decreasing the key value. क्योंकि अगर इसको डिक्रीज करना है तो कोई इश्यू नहीं है. सपोज भाई जैसे आपको इसकी वैल्यू को रिप्लेस करना है, तो जब ये वैल्यू रिप्लेस होगी तो इसको हम ऑटोमेटिकली वैसे रिप्लेस कर सकते हैं अगर स्मॉल वैल्यू से करना है. तो इतने सब इसकी ऑपरेशंस की जरूरत नहीं है, बिकॉज जब ये स्मॉलर वैल्यू से रिप्लेस करेंगे देन there will be no max-heap properties violation over there. Okay, but if we are just replacing that value by a greater value, then it may be possible like the max-heap property will be violated over there. तो सबसे पहले हम ये चेक करेंगे कि क्या जो नई की है वो AI से स्मॉल है. अगर वो है then we will just print a message over there like new key is smaller than the current key. So the operation is not possible. Okay, now we will simply replace the key into the AI or assign into AI the key value. तो ये हमने क्या किया, अगर कंडीशन फॉल्स है तो हमने जैसे 15 है 15 को यहाँ पे रिप्लेस कर दिया. अब 15 को रिप्लेस किया तो हमको टुवर्ड द पेरेंट हमको चेक करना है कि ये कंडीशंस हमारी फुलफिल हो रही है नहीं हो रही है. जैसे यहाँ ये कंडीशन वायलेट हो रही है, द वैल्यू ऑफ after 15 comes here, the value of the child node of 8 will be greater than to this. So it is violating the properties of the max heap. So what we will do, while I greater than 1 means we are at here, we will go toward this, and a of parent I less than ai means both condition must be true. या तो हम रूट तक जाएं और या फिर पहले ही हमारी कंडीशन सेट हो जाए. ठीक है, और अगर this loop will execute for both these condition true, then what we will do, simply exchange the value of ai with a parent. अभी ai ये है, इसका parent ये है, यहाँ हमने इनको exchange किया, फिर यहाँ exchange करेंगे, फिर suppose ये जो value थी हम यहाँ पे 25 insert करते, तो रूट तक process यहाँ पे execute होता. ठीक है, and after just increasing that value, just make the value I as the parent of I. So it will, this operation will execute it till the root. Now what we are simply doing here, we are in the worst case, ये operation कब तक होगा, इस ट्री की हाइट तक होगा. मीन जैसे हम यहाँ पे लास्ट लेवल पे हैं और यहाँ से फिर हम इस पे गए अपर लेवल पे, फिर अपर लेवल पे, फिर अपर लेवल पे. So this operation will get executed up to the height of the tree. Okay, so the running time of this heap increase operation will be that is log of n. So we have studied 3 operations till now: the getting the maximum with the cost O of 1, and extract max with the cost O of log n, and this heap increase keys with the cost of O log n. Okay. Now the last operation that can be implemented or applied on this priority queue when we are implementing it via the heap That is the insertion operation. So the goal is insert a new element into a max heap. तो अगर किसी लोकेशन पे कोई हम एलिमेंट इंसर्ट करते हैं तो फिर क्या प्रॉब्लम होगी? So what is the process for this purpose? The process is just expand the max heap with a new element whose key is infinity. तो हम क्या करेंगे? अच्छा, इंसर्शन कहाँ पे होगा? बिल्कुल लास्ट लोकेशन पे जाके होगा. तो इनिशियली हम क्या करेंगे? We will insert a value that is minus infinity. And then we simply call the max-heapify procedure for the actual value which we want to implement there. So expand the max heap with a new element whose key is minus infinity, initially this. Now call heap increase key, sorry, max-heapify nahi, heap increase key, to set the key of the new node to its current value and maintain the max heap property. ठीक है, तो ये 15 इंसर्ट होगा यहाँ पे, तो क्या होगा फिर अगेन वही प्रोसेस होगा. वी विल जस्ट गो टू द रूट एंड place it at its accurate position. So like start by inserting infinity, then we just replace call for heap increase key on the 11, a of 11. This is a11. 1 2 3 4 5 6 7 8 9 10 11. Okay, so a11 equal 15. Then the properties of the heap will be restored by just going towards the root and setting or placing this new key at its appropriate place. So now we have restored the heap containing the newly added element, and we have just satisfied all the properties of the max heap. So this is the basically operation of max heap insert. Okay, and this is the algorithm for max heap insert. तो ये भी कोई बड़ा टास्क नहीं है यहाँ पे. वी आर जस्ट दिस इज द एरे, दिस इज द की विच टू बी इंसर्टेड, एंड दिस इज द साइज ऑफ द हीप बेसिकली. तो जब एक नया एलिमेंट आ जाएगा तो क्या हो जाएगा? द हीप साइज विल बी इंक्रीज्ड, एंड इनिशियली वी आर इंसर्टेड द वैल्यू माइनस इन्फिनिटी देयर. और अब हम क्या करेंगे? वी सिंपली कॉल दिस हीप इंक्रीज की ऑपरेशन. तो वी वांट टू इंक्रीज द वैल्यू, इसीलिए इसको माइनस इन्फिनिटी लिया है कि जो भी कि आप इंसर्ट करोगे वो उस माइनस इन्फिनिटी से ज़्यादा ही होगा. ठीक है, सो माइनस इन्फिनिटी या एक बहुत मतलब ऐसी वैल्यू जो बहुत स्मॉलर वैल्यू है, जिससे फिर हम जब हीप इंक्रीज की प्रोसीजर कॉल करें तो वहाँ पे कोई प्रॉब्लम नहीं है, लॉजिकल एरर नहीं हो. ठीक है, सो नाउ वी वांट टू टॉक अबाउट द कॉम्प्लेक्सिटी ऑफ दिस. तो देखो इसमें कुछ बड़ा टास्क नहीं है. ओ ऑफ वन कॉस्ट, ओ ऑफ वन कॉस्ट, और उसकी कॉस्ट हो जाएगी ओ ऑफ लॉग एन. So the cost of the whole operation max heap insert will be O of log n. So these are the 4 operations which can be applied on the priority queue when we are implementing the priority queue using the max heap. So these are the operations which we have applied on the heap, like max heapify with the O of log n operation, max build heap with the O of n operation, heap sort O of n log n operation. अच्छा, इसमें देखो सबसे पहले देखा था हमने heap maximum O of 1, और हीप एक्सट्रैक्ट मैक्स ओ ऑफ लॉग एन, हीप इंक्रीज की ओ ऑफ लॉग एन, और हीप मैक्स हीप इंसर्ट दैट इज ओ ऑफ लॉग एन. तो ऑन एन एवरेज देखें तो इसमें जो सारे ऑपरेशंस हो रहे हैं उनकी कॉम्प्लेक्सिटी क्या हो रही है? इट इज इन टर्म्स ऑफ द ओ ऑफ लॉग एन. ठीक है, ये सारे जो प्रायोरिटी क्यू में जो सारे ऑपरेशन हो रहे थे, जब हम प्रायोरिटी क्यू को इम्प्लीमेंट कर रहे हैं यूजिंग द हीप, तो दीज आर द एवरेज नंबर ऑफ ऑपरेशन ऑन द प्रायोरिटी.